Yo, 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 chemistry. Hey guys, how you doing? Hope you're all well. Miss you guys immensely. Again, down in my classroom, as you guys saw from the welcoming video, just working on stuff like usual, trying to get you guys as much chemistry as I can and get you guys dialed in for the rest of the year. So last week we talked about energy, and we were talking about the amount of energy that's released in water, and we're using water as our specific heat since it's the most abundant fluid, basically the substance on this planet. And so we're using that within temperature changes and calculating how much a temperature change would influence the amount of energy released. So the specific temperature of water was 4.184 joules per degree per gram degree Celsius. But today we're going to start looking at specific heat calculations, and I'll make two different videos for you guys. The first one is calculating the amount of energy that's released due to the specific heat of an object and its temperature change. So every object on this planet has its own specific heat. So steel has its own specific heat depending on the type of steel. Copper, lithium, gold, neon, all these elements, all these combinations of even different compounds have specific heats that are associated with them. So in this case, I'm giving you guys specific heat. We're just calculating how much energy is released. So in this case, J, I'm looking for the joules. So I'm missing this, but I got a sample size of 10 grams. I didn't put in a starting temperature and ending temperature just so I could fit these two problems together. But it says that the change of temperature that I'm occurring within this reaction is taking 33 degrees Celsius. And S, this little S for you guys now, is the specific heat capacity of an object. So in this case, my specific heat capacity is 0.90 joules per gram degrees Celsius. And this is the specific heat of aluminum. And I know right down here I wrote lithium out, but not all the way aluminum. I don't know why. But this is aluminum. So aluminum has a very low specific heat temperature. So it heats up readily and also is a good way of dissipating heat a lot of times too. So engine blocks a lot of times are aluminum. That way it can dissipate that heat as it cools. So just another little thing there for you. So if I plug and play just to see how many joules I've got my 10 gram sample. And I didn't put my G's in there, but I just plug and play really quick. 10 grams times my change of temperature, which is 33 degrees Celsius, times the specific temperature or specific heat capacity of aluminum, which is 0.90 joules per gram degrees Celsius. And if I plug that together, I'll come up with a total of 297 joules worth of energy that are released when that sample is heated up to 33 degrees or cooled down to 33 degrees, depending on which way we're working. Second problem, again, I don't know joules, but I got a sample size of 25 grams. I got a change in temperature of 15 degrees Celsius, and my specific heat capacity is 3.56 joules per degree or per gram degrees Celsius, which is the specific heat capacity of lithium. So remember that lithium, that little metal that we threw in water, and it tinkers around a little bit, turns pink, lights on fire, and goes pop, has a fairly high heat capacity compared to things like aluminum. So in this case, I got my 25 gram sample. My change is 15 degrees Celsius. And then my specific heat capacity is 3.56 joules per gram degree Celsius. And if I multiply this all together, I'll get 1,335 joules. So that's how you calculate the energy given the specific heat. You need the specific heat, you need the temperature change, and you need to know the sample size. And if you got those three together, you can calculate the amount of joules that are released. Next thing we're going to work on is, given the amount of joules and given a sample size and given a temperature change, what's the specific heat of that object? So for this one, I'll give you guys a worksheet or a key that shows you the specific heat capacity of things. So that way you guys can use as a reference. And we're just going to kind of work through these this way, as well as solving for the unknowns. And again, if you guys have any questions, concerns, you're not understanding this, you're having a hard time submitting assignments, reach out to me. You guys know how to do that. I'm readily available, and I want to help you guys through this. So I miss you all. I really do. I've been wanting to blow up stuff in my backyard, but I have a feeling that if I do that, the Ocean Shores Police Department will know it's me and be coming over soon. But I gotta do something, so stay tuned. Maybe I'll do a demo down in the classroom this week. Let me know what you guys think on that. It'd be kind of cool. Yeah, hope you guys are all doing well, and stay tuned for part 2. All right, love you guys. Peace.